Alright, in the last lecture we have learned common operations that can be performed on circular queue in the list implementation. Now in this lecture, we will implement a queue using linked list. So let's see how it works. To create a queue using linked list, firstly we need to create an object of single linked list class. So when we create an object of single linked list class, it basically creates a blank head and blank tail. So the references of head and tail here sets to null. And there is not any node in this list over here. So with this, creation of a queue using linked list complete. So once we created a blank queue, the next thing that we are going to do is we need to enqueue elements to this queue. So let's see how do we do that. So the first thing that we are going to do over here is we need to create a blank node. And we need to assign a value to it. Then we need to change head reference and tail reference to point to this node over here. So we know that the physical location of this node now is 111. So we are setting the head reference to 111. Then we are setting the tail reference to 111 to point to this node over here also. So by setting a tail reference to 111, we are creating a link between tail and this newly created node over here. So after completing these steps, a new element will be enqueued to the queue. Now if we want to insert another node over here, once again we will create a new node and we will assign a value to it. Then we need to create a link between first node and this newly created node over here. Now we know that the physical location of this node is 222, so we will set the first node's next reference to 222. So by setting it, we are creating a link between first node and this node over here. Then we need to create a link between tail and this node over here. So we will set the tail reference to 222, and this will create a link between tail and this node over here. Then by creating a link between tail and this newly created node, the previous link between tail and the first node gets destroyed. And with this, a new element has been added at the end of the queue. Because here we are adding end of the linked list, and here also we are adding end of the queue. So let's try to add one more element to this queue over here. So once again, the steps are same. So here we need to create a new node and then assign a value to it. So in this case, the value of this node is 3. Then we need to create a link between the last node and this newly created node. So how can we create the link between the last node and this newly created node? So if we set the next reference of this last node to the physical location of this newly created node, we can create a link between them. So we know that the physical location of this newly created node is 333. So we will set the next reference of last node to 333. By doing so, we are creating a link between last node and this node over here. Then we need to create a link between tail and this newly created node over here. So in this case, we will set tail reference to the 333. So this will create a link between tail and this newly created node, and the link between tail and the last node gets destroyed. And then this element is added at the end of the queue. Now basically every time when we enqueue a node, we are inserting the node at the end of the linked list. Because in queue, when insert an element, we insert at the end of the queue. Now this is how enqueue operation works in the queue in case of linked list. Now let's see how the dequeue method works in the queue. So if we want to dequeue an element from the queue, we know that the first entered element must be removed first. This means that in this case we need to remove first element from the linked list because when we enqueue an element to the queue, in the case of linked list we are adding it to the end of linked list. So the first node is always the one which is inserted first. So in this case, when we call the dequeue method, we need to remove this element from here. So we know that to remove an element from the beginning of linked list, we need to destroy a link between head and this node over here. So we need to set head reference to point to the second node over here. We know that the second node's physical location is 222. So we will set head reference to 222. By setting it, we are creating a link between head and second node over here. And then the link between head and the first node gets destroyed. Now this node becomes eligible for garbage collection. So we are returning this node and the garbage collector comes and deletes this node from here. And this node will be returned from the queue. Now if we call the dequeue method one more time, then it will return this node from here. because this node is now the first node in our linked list. So once again, we need to create a link between head and second node. So in this case, the second node's physical location is 333. So we will set head reference to 333. By setting it, we are creating a link between head and this node over here, and the link between head and the first node gets destroyed. So one more time, this node becomes eligible for garbage collection. So we are returning this node, and the garbage collector comes and destroys this node from here. And this element enqueued from the queue. Now let's continue to the next method. The next method is pick method. So we know that in case of queue, pick method returns the first element from the queue. So in this case, we have to return the first element from the linked list. So we know that to return the first element from the linked list, we just need to return the value of head. So in this case, we are returning the value of head, and we are not updating the first element of the linked list. This is similar to the queue method, but in case of pick method, we are not updating the first element in the queue. We are just returning it. It doesn't matter how many times we call pick method, we are just returning the first element without updating it. Now the next method is empty method. So in case of linked list, to check that if we have any nodes or not, here we will check head reference. So if head reference points to none, it means that we don't have any element in the linked list. So in this case, our queue is empty. So we will check that if head is none, we are returning true. Otherwise, we are returning false. So if head is none, our queue is empty. Otherwise, it's not empty. We have at least one element in our queue. Now, before continuing to the next method, I just want to mention that in case of linked list, we don't have isFull method, because here we don't set any capacity for the linked list. That's why isFull method is not applicable over here. Now, the next method is delete method. We know that delete method in case of queue is responsible for deleting all elements from the queue. Now, in case of linked list, to delete all elements from the queue, we just need to set head and tail references to none. So when we set the head and tail references to none, the elements becomes eligible for garbage collection one by one. So if we set head reference to none, the link between head and first node gets destroyed. Then if we set tail reference to none, the link between tail and the last node gets destroyed. Now in this case, the first node becomes eligible for garbage collection because here there is not any link that points to first node. So firstly, the first node will be deleted by garbage collection. Then after deleting this, the second node becomes eligible for garbage collection. So the garbage collector comes and destroys this node over here. Then the third node becomes eligible for garbage collection because as you see, there is not any link that points to this node over here. So the garbage collector comes and deletes this node from here as well. And it's removed from the queue. Now these are the all operations that we can perform on queue using linked list. Now in the next lecture, let's use this logic and create queue using linked list and implement operations in practice. See you in the next lecture.